Hello, my name is Atiya Razi and I'm a teacher at Simcoe County District School Board in Canada. As a part of my Master of Arts in Education and Technology from Michigan State University, I created a digital story about grade 2 science concept, How Seasons Change. From my teaching experience and discussion with my other teachers, I already know that most of this time the students have a misconception about the season change. My lesson involves the element of social constructivism learning theory, and it is built off prior knowledge, and then the lesson is supported by cognitive constructivism learning theory. Piaget's learning theory of cognitive constructivism is based mainly on the fact that a teacher must build on the students' prior knowledge, and in other words, they'll construct on what they already know to improve understanding. I'll challenge and guide my student thinking to a complete understanding. Using this strategy, I hopefully challenge my students to think critically and discover new information and eventually clear prior misconceptions. According to Vygotsky's social constructivism theory, knowledge is socially constructed and built on what participants contribute and construct together. The students of various skills and background will learn collaboratively and construct socially defined knowledge and values. Prior conceptions and new concepts are interwoven together. The teacher facilitates the learning where a student will actively involve in thinking, explaining, interpreting, and questioning to co-construct learning with them and others. I'll use the feature of Vygotsky's zone of proximal development in my lesson, that is the area between the child's level of assisted performance and the child's level of independent performance. Earth and space are very important topics covered in all grades in science. It ranges from seasonal change to the climate change due to the human activities, and each of them are interconnected in one way or the other. Correct concept of why season change. The seasonal changes are caused by the tilting of the earth about the sun's rays. As the sun goes around its orbit and the northern hemisphere is at various times oriented more toward or more away from the sun, and likewise for southern hemisphere. Seasonal change is explained by the changing of angle of Earth's rotation axis towards the Earth's orbit, which causes an alteration in light angle toward a concrete place on the Earth. I started my lesson by whole class discussion to get my students prior understanding about why seasons change. My students shared many great ideas about the seasons, but I found that they still contain some misconception about why seasons change. For example, most of my students think that seasons on the earth are caused by varying distances of the earth from the sun on its elliptical orbit. I think that most effective way to meet a student's learning need is to work toward them by the beginning wherever the child is, otherwise prevent the development of essential fundamental understanding and skills needed for the future success. To facilitate and scaffold their understanding through Vygotsky, I showed an animated video that contains their favorite characters.
Imagine that you live in North America, and one day you call up your friend in Australia. You guys are talking and you make plans to go visit him next summer.
So, anytime next summer works for you?
Yep, whenever's best for you. Surprise me.
In a few months, July rolls around and you hop on a plane for your Australian vacation. Imagine your surprise when you show up at his house and he tells you,
"What are you doing here, mate? It's the middle of winter."
and then you say,
Winter? It's the middle of summer back in America.
and your friend's like,
I don't know what to tell you. July is winter for us.
Okay, I don't get this. How can it be summer in America and winter in Australia at the same time?
that's a great question. I think we can help you out with that. To answer this question, we have to zoom way back and start with a top-down look at the Earth's orbit around the sun. Oh, by the way, everything you see in this video isn't to the correct scale. Now, the Earth's orbit isn't a perfect circle. It's actually an ellipse. You usually see it drawn like this. Lots of people think,
Hey, this must be why we have seasons. When the Earth is close to the sun, we have summer, and when the Earth is far away from the sun, we have winter.
but that's actually not true. If that were true, it would be summer in America and Australia at the same time.
And we know that's not the case.
Exactly. The way we've drawn Earth's orbit here is really exaggerated. People just draw it that way to highlight the extremes. In actuality, there's a relatively small difference between the Earth's closest and furthest points from the Sun. If we draw Earth's orbit with the correct shape, it looks like this. You can see it's actually pretty circular, but it's not perfect. So it's not the closeness of the Earth to the Sun that causes the seasons. To see what's actually at work, we have to look at the orbit from the side. In our side view, the Earth is revolving around the Sun in this orbital plane here. It takes 1 year to go through a full orbit, 365 days. Remember, at the same time, Earth is rotating on its axis once every day. The important thing, for the seasons at least, is that the Earth actually isn't straight up and down. It's tilted at an angle of 23.5 degrees. So, when the Earth is on this side of the Sun, the northern hemisphere is angled away from the Sun. The southern hemisphere is angled toward the Sun. When the Earth is revolving around the Sun, it stays tilted in the same position. The axis doesn't wiggle around or anything. It just stays fixed in a certain direction. So when the Earth is over here, the northern hemisphere is angled towards the Sun, and the southern hemisphere is angled away. When a hemisphere is angled towards the Sun's rays hit it directly. That's what's happening in the northern hemisphere here. But when a hemisphere is angled away from the Sun, like the southern hemisphere here, the Sun's rays hit it indirectly.
Okay, so what difference does direct or indirect sunlight make?
Oh, there's a huge difference. Let's take a look with a simple experiment. In this experiment, we're going to use a flashlight to simulate the Sun. Let's take a look at what this means for the Earth. Here we have a globe that's angled at about 23.5 degrees. It's June, so the northern hemisphere is angled towards the Sun. If we shine the flashlight directly on the northern hemisphere, we see it illuminates a certain area. But when we move the flashlight to shine indirectly on the southern hemisphere, we see that it's illuminating a larger area, just like we talked about. So let's put it all together. When the northern hemisphere is tilted towards the Sun, it's receiving direct sunlight. It feels warmer, which means it's summer there. And the southern hemisphere is receiving indirect sunlight, which means it feels cooler. That's winter. 6 months later, when the Earth is on the other side of the Sun, we have the opposite. It's the southern hemisphere receiving direct sunlight, so it's summer there. And the northern hemisphere is receiving indirect sunlight, so they're having winter. And now you know the reason for the seasons.
Awesome. So it's not how close the Earth is to the Sun that matters, but instead it's the tilt of the Earth.
Which is also why it's winter in Australia at the same time as it's summer in America.
You got it.
Well, I think this has been the most educational vacation I've ever had.
I allow my students to perform think, pair, share activity. They work together, share ideas, and learn by themselves and by peers. The students construct their understanding socially and gradually. The twist in my lesson happened by observing my students. I was very happy and surprised by their performance as they shared their understanding in a variety of ways in their presentations. According to Piaget, the learning occurs through multiple opportunities and diverse process to connect their prior understanding. The students were able to think critically and actively engage in constructing their own learning. To scaffold and facilitate their learning and understanding, I gave them exit cards to write down what they know about the season change. From the feedback of the student in their exit cards, I can say that now that a student can comprehend the correct concept of seasonal change. I believe that by providing personalized learning, respecting the diverse needs of all learners, providing the opportunities to learning through discovery, and integrating technology positively, thoughtfully, and appropriately can bring us success and confidence in our students. Thank you.